so similar to every other day, what we're going to do is we're going to look page by page. You guys are going to tell me what you want to go over. We're going to do the second half of chapter 2, and then chapters 3 and 4, so about 2 pages. On this page, what do we want to go over?
All 12.
12? What else besides 12? 9? 10. Bless you. 10, 12, Miranda? 11. 9. We all good on 8?
Yeah, no, it's easy.
You want to go over 8 also?
No, I'm good.
Okay. Problem 9. What form is this called?
Point slope.
Point slope. So it gives you 2 pieces of information. It gives you the slope and it gives you a point. What is the slope? 3 over 2. So this right here is our slope. Okay. What you all tend to be not so great at is finding the point. Okay. In a point, what comes first? X or Y?
X.
X. You're always going to go here first.
Negative.
Is it 2 or negative 2?
Negative.
Negative 2.
Comma
3.
three.
So if you remember, in point slope form, you're always subtracting. That's the reason you have to switch the signs. Okay, so you're going to start with that point, negative 2, 3. And then I need a slope of 3 over 2. If I go down 3, which way am I going to go over 2 to have left? How do you know left? Because I know a lot of you like up. Positive slope should go up. So then down 3 over 2 again. You need to make sure that you have a straight edge for the final. Yeah, ID, straight edge, something you can use. So that is our line. Problem 10, given the piecewise function, find f of 5. The worst thing you can do is plug 5 into both equations. Which equation am I going to use, the first one or the second one? Second one. Donovan, why the second one?
5 is greater than 2.
You're going to look here. So in this case, 5 is greater than 2. That's true. So I use the second equation. 5 is not less than or equal to 2, so I'm not going to use the first one. So my f of 5 then is going to be negative 6 plus 2 times 5. 2 times 5 is 10. Add a negative 6 gives me 4. Yep, that's it. Problem 11. Does the set of ordered pairs below determine a function? What do we look at? The x's or the y's? X. I'm looking to see if any x's repeat. Do any x's repeat?
No.
Yes. 0. 0
Oh.
repeats. Okay, in this case, is this a function?
No.
Yes.
Yeah.
No, this is not a function. So x equals 0 has 2 different y's, or outputs, yes. So in order for this to be a function, each x has to have only 1 y, not 2. Okay, 12. In 1981, 6 to 8-year-olds spend an average of 40 minutes per week doing homework. By 2003, the time they spent doing homework has increased to about 150 minutes. A, set up 2 ordered pairs. This is really important. Let x equal the number of years since 1981.
So that'd be 0.
Right, so in 1981, that is year 0.
40.
They spend 40 minutes on homework. 2003, what is going to be my x value? 22. Do you all know how Casey got that? Casey, can you tell us, just in case people don't know how you got that?
Subtracted 2003 from 1981.
Yeah, so if 0 is the year 1981, I'm going to subtract the 2, gives me year 22, and this is 150 minutes spent on homework. Okay, find the slope of the lines. Slope is going to be y minus y, so 150 minus 40 over x minus x. So this ends up being 110 over 22. Anybody happen to know what 110 divided by 22 is? It is 5. Okay, units on the slope. It's y over x. What are the units for y?
Y is minutes.
Minutes. What are the units for x?
Year.
Year.
Yeah.
So can somebody tell me what this means?
Yeah.
Yeah, every year on average, 6 to 8-year-olds are going to spend another 5 minutes on homework. An extra 5 minutes. C, write the particular equation. So write the equation between x and y. That's all it's asking. Would we like to use point slope form or slope intercept?
Point slope.
Point slope. Could we use slope intercept if we wanted to?
Yeah.
Oh yeah, actually we should do that.
We have the y-intercept. This is the y-intercept. So I'm going to use that one because I prefer that form. So I get y equals 5x plus 40. So y equals mx plus b.
7.
Nope. It says then use the equation to predict the number of minutes of homework in 2010.
So
Okay, so 2010
30.
is year 29, I think. Bless you. Bless you. So if you do 2010 minus 1981, that gives you 29. So if we do 5 times 29, add 40, gives us 185 minutes. Questions on slope, graphing, anything like that? Okay, flip the page. Chapter 3 was systems of equations and inequalities. Do we want to go over substitution or elimination? Yes? Both or one? Both. Okay. We're going to go over substitution. We're going to go over elimination. Do we want to go over graphing inequalities?
Yeah, might as well.
Okay.
Might as well. Do it.
Problem 1, substitution. What does substitution mean? What method is that?
Making x or y equals something that's plugging it back in.
Yeah, very good. You're going to solve for x or y. Chris, what is your suggestion for problem 1? Do you want to solve for x or y, and in which equation?
The first one solve for x.
Yeah, always solve for whatever equation has a leading variable of 1. So there's nothing in front of this x, so we're going to solve for x. We're going to move 3y over, so we get negative 5 plus 3y. So now that's going to go in for x in the second equation, not the first one, second one. So we get negative 2. Instead of x, though, x is the same as negative 5 plus 3y.
Plus 3y.
What's my next step?
Distribute.
Distribute the negative 2. So I get 10 minus 6y plus 3y equals 10. Ooh, this is a good one. What am I going to do with this 10?
Minus it.
Subtract it. Negative 6y, add 3y is negative 3y. 10 minus 10 is 0. Okay, when we did this chapter, a lot of you got to this point and you wrote no solution.
No.
Not no solution. What does y equal here?
0.
0. Yes.
So then you put.
Okay, I have a whole bunch of options of where I can plug x or y back into, rather, to find x. What is the easiest one?
First one.
How about over here?
Oh.
So I'm going to use this equation. So I get x equals negative 5 plus 3 times 0. So x equals negative 5. So my ordered pair is negative 5 comma 0. If you do not write it as an ordered pair, I will not give you credit. Now, is it possible to check our answer?
Yes.
Yes, then check your answer. It's silly not to if you can check it. So let's check negative 5 comma 0. Negative 5 minus 0 equals negative 5. That's good. Negative 2 times negative 5 is 10. 10 plus 0 equals 10. That's good too. Okay, problem 2. Linear combination, that's the same thing as elimination. What is the general idea with elimination?
Take away a variable.
Yeah, take away a variable. We need to get the numbers in front of the x's and the y, or the y's to be the same with different signs. Devin, would you like to eliminate x or y?
X.
Okay, x. So we're going to eliminate x. They already have different signs. Is there anything we can multiply 3 by to get 11?
No.
No. That tells us we're going to have to multiply both equations by something. Devin, what would you like to multiply the top equation by? 11. What would you like to multiply the bottom equation by? 3. Okay, so we get 33x minus 77y equals 220. Please make sure you multiply the right side by that number. You guys tend to forget that. Then we get negative 33x plus 30y equals 15. Nathan, how do we know that we're on the right track?
The 33x on top and the negative 33x on the bottom cancel each other out.
Very good. When we add these together, those x's are going to cancel each other out. Negative 77y add 30y is negative 47y equals 335. Is somebody checking my work?
Yeah.
Okay, because this seems a little fishy to me. Ah, okay, there we go. Thank you. 235. Whew. Okay, let's see if that works out better. It does. That gives us a y of negative 5. Matt, how am I going to solve for x from here?
Plug in the y
Where?
into the first equation.
Okay. Could I use the second equation if I wanted to?
Yeah.
Okay. Let's use the first equation, though. 3x minus 7 times negative 5 equals 20. Please be careful here. 7 times negative 5 is what?
35.
Positive 35, yes. Equals 20. If I subtract 35, I get 3x equals negative 15, and x equals negative 5 again. Huh. So I get negative 5 comma negative 5. Let's check that. 3 times negative 5 is 15.
What? Plus the
Negative 15 plus 35 because this gives us 20. 55 minus 50 gives us 5. So that works. Questions on substitution elimination? I will not give you a 3 by 3 system. So I'm not going to give you 3 equations that have all 3 variables. Those really hard ones, I won't give you those, just so you know.
No, those were actually not that bad.
Yeah,
They
I
just
know.
took a while.
Okay, problem 3. First one, y is greater than 1/2 x minus 3. What form is that?
That's slope. Points. Oh, slope and
Slope intercept. Our intercept is negative 3. Is negative 3 on the y-axis or the x?
y.
The y. So I go down negative 3.
1 over 2.
Yep, slope of 1/2. So up 1 over 2, up 1 over 2.
It's a dotted line.
Yes, that was going to be my next question, is what do I have to be careful of? It's going to have to be a dashed line because there's no equal sign. What else do I have to do before I can go on? Figure out shading. Lizzie, how am I going to figure out where to shade?
You plug in a number that's not on the line.
Yeah, what do you think is the easiest point to plug in? Yeah, let's plug in 0, 0. So we get 0 is greater than negative 3. True or false?
True.
True. So I'm going to shade toward 0. Okay, x is less than negative 1. Josie, horizontal or vertical line?
That way.
Yep, up and down. Going through negative 1. Right, it is negative 1. Yeah.
Yeah.
Joanna, which way am I going to shade? Left or right? To the left. Less than negative 1. Less than is to the left. Lastly, make sure you shade where all the overlap is. Okay, we have one more question to do. Is that okay? One more and then we're done, and it's not even a graphing one. It's a matrix question. Okay, so we need to solve for x, y, and z. I will tell you right now, because this is the final and not the matrix chapter, I don't care what method you use. So, do you all prefer inverse matrices or RREF? right? RREF. Okay, so here's the work I expect to see. You need to show me what matrix you're putting in. We're going to go X, so 4, Y is 1, Z is 6, and then 7. So you have to make sure you always go X, Y, Z. Then I'm going to do 3, 3, 2, 17, -1, -1, 1, -9. Okay. Okay, can anybody tell me where to go from here? So how do I put this matrix in the calculator? Second matrix. Go over to edit. What are the dimensions?
It's a 3 by 4.
3 by 4. 3 rows, 4 columns. Then put all your numbers in. So 4, 1, 6, 7, 3, 3, 2, 17. -1, -1, 1, -9. Okay, then I'm going to go second quit and quit out. Where do I go next? Back to second matrix. This time we are doing some math with this matrix. I'm going to go backwards and go to RREF. Then if you do second matrix, choose matrix A again, hit enter. Now, does this system have a solution?
Yeah.
Yeah.
Okay, because not every system does. How do we know that this system does in fact have a solution?
1, 1, 1.
What is this called, this first matrix here? With the 1s and the 0s? Has a special name.
Inverse.
Starts with an I.
I'm inside.
We don't remember. I heard inverse the first 3 times you said it.
Is that not right?
That's not right. That's why I haven't acknowledged it.
Oh, it's the
What do you call who you are as a person?
I.
That starts with an I.
Identity.
Identity. You guys remember the identity matrix? Does that sound familiar? Not at all? Okay, 4, 3, -2. Okay, so this becomes 1, 0, 0, 0, 1, 0, 0, 0, 1.
The last column.
And then 4, 3, -2.
What's your answer?
Where do I look to find the answer? The last column. So that is our answer. 4, 3, -2. Donovan.
We need to know the ones where the identity is like all zeros or something. It's like
Yeah. Okay, Donovan is saying, what happens if I get something like this? So let's say that this is for a completely separate problem. I don't have the identity in this case. If I don't have the identity, it's either infinitely many solutions or no solution. Where do I look?
The bottom row.
The bottom row. What does that tell me?
Wouldn't that be no?
What, Chris? No solution. We had 0x plus 0y equals 3. 0 plus 0 equals 3. Make sense?
no.
No. That's why it is no solution. If it's infinitely many, what will the last row look like? All zeros. All zeros. Questions on anything we talked about?
Nada.
Chapter 5, that first problem, can you guys just cross it out so you're not tempted to do it because you don't know how? We never did it. Oh, and then there's another problem we also didn't do. This problem here. I don't know if I told you to cross that out. Next page, very last problem, problem 5. You can cross that out because we never did it.
Oh, it's already crossed.
Oh, it's already crossed out. Good for me. Okay. Any questions?
Nada.